keep on responding from this chat box. It's good to see. Right now we have got 33 participants. Yes, Satish, today we have got many more registrations across the states. So we are strictly conducting today's session in English. I hope it is fine. Everybody should be okay with it. Yes, Vikrant, you can ask your queries in Hindi also. Actually, language is not at all a barrier for us, since this is a program on science and technology. But since we have got many non-Maharashtrians as well, so we are keeping it in English. Hindi should be also fine, no issues with that.
Hello everyone, this is Vibhag from Maharashtra Seva Sangh. I hope I am audible to all of you, and basically I will be managing the session from the back end on this side as Maharashtra Seva Sangh's volunteer. We are having this session as part of our Vidnyan Vibhag's online knowledge series, as my friend Sachin was explaining to you all. The speaker for today's session is Karan Chaphekar, 3D printing expert. He would be speaking on the different techniques we have in 3D printing. It would also be followed by a live demo. And as Sachin explained to you all, you would be asking your questions in the chat. And if time permits, we'll have the Q&A session at the end. But do keep asking your questions in the chat. One of us will be recording the same and asking it to the speaker for today's session, that is Karan. We will be starting very soon, and I hope people will join us quickly as soon as possible. If you have your friends, family, anyone who is expected to join, please ask them to join in the next 2 or 3 minutes, as we will be starting very soon. Also, I would request all of you to please turn off your video, because we would like the host or the speaker to share their presentation and be visible to everyone else. And in that case, if your video is on, other people may not be able to see the speaker, as it may switch between yours and the speaker's screen. So please, if anyone has turned on their video, I request you to please turn it off.
Alright, now we'll start this session. Namaste, my name is Sachin Vaje. I'm a volunteer at Vidnyan Vibhag of Maharashtra Seva Sangh Mulund. And we are happy to see that we have got a very good response for today's session. Before we begin, I would like to request everyone to please fill out the feedback forms after the end of this session. We will share the link for the same. Your feedback, your suggestions are very important to us for improving our programs further. Also, in today's session, we are going to have separate Q&A session only if time permits, as I talked before. So keep on asking your questions from the chat window. Now let's move into our today's topic. I'm getting some noise. All right. So let's move into our today's topic. The idea of printing something in 3 dimensions itself is like very fascinating. So today let's know more about it from a young 3D printing expert. I'm extremely delighted to introduce our speaker, inventor of India's first low-cost 3D printer machine, Karan Chaphekar. Karan is from Thane, Maharashtra. He was my classmate during my bachelor's degree course in electronics engineering. Since then only, he was very much passionate about learning and implementing this technology. Currently, he is working as a technical consultant. He also used to take workshops for Atal Tinkering Labs in Ryan Group of Schools. While working on engineering projects, many times we need different kinds of spare parts. A lot of time gets wasted in finding the exact shape and size. So Karan thought about having a machine which would make the actual parts. So he ended up implementing India's first low-cost 3D printer. And amazing thing is that this machine is capable of building a replica of itself. Now let's dwell into this exciting topic. I'm not going to take any more time. I think Vaibhav, you can now hand over to Karan. Thank you so much.
Thanks Sachin for the introduction, and we have with us the speaker today, that is Karan Chaphekar. I would be now giving him the access for the session today, handing over the session today. Karan, I think you should be able to share your presentation and speak also.
Sorry, I'm getting the access on my mobile phones. I have another one which is Karan Chaphekar PC.
Yeah.
Thank you very much. Good morning, everybody.
Karan, can you switch the presentation view?
Yes.
Currently, yes.
Yeah, I'm just sure. Just wait a second, let me solve this technical issue. Okay. Can everybody see? I think so, yeah. So, my name is Karan Chaphekar. I'm in doing this kind of electronics projects and all since I would say my childhood. I think so first sort of notable project I did when I was in 5th standard, and that was my motivation to do it. So today we are going to talk about this concept of 3D printing. Okay, so 3D printing is like very buzzwordy. You must have heard it for like, I would say now it's popular for like 4 to 5 years more popular. It's in our common conscience. If you even see some latest blockbuster Marvel movies, you can see 3D printers in them. So 3D printers are becoming this mainstream thing, but let's understand what it is. A little bit about me. I tried to do my bachelor's of engineering I was not good at academics. So when I was dropped out, so I was doing these kind of projects. So this is one of my printers. So let me say what is 3D printer. So 3D printer is an additive manufacturing method. So additive manufacturing, where instead of taking like a block of wood and we carve the wood to make our object, instead of here we are adding material to make it. And this technology is about 30 years old. It was used by NASA also for some space shuttles. But why we are talking it about now? The reason is patents. What happened, the patents for this technology, which is FDM technology that we are going to focus on, where we put the plastic material using a mechanical system, has expired in about 2009. And because of that, then the project started parallelly. Let's try to develop our homegrown 3D printer. So that was the concept. So this is an example of a normal manufacturing that you might be known of, where you take the whole material and using a drilling machine, or they are called end mills, you try to make your part, whatever you want to make. But in additive manufacturing, this is an example of a 3D printer. You can see this a DNA structure. This DNA structure, where it's like made out of adding material. It is, so the main thing is your wastage of material is pretty low. One more thing I want to mention here is this whole project. This is not my invention per se. It's more about the implementation is unique for myself. So this is whole open source project. What an open source project means, the main files that are made, whatever the software, whatever the hardware, are freely available. So you can also make your own 3D printer, okay? Because the community of 3D printer, 3D printing enthusiasts have came together to make this possible. So we are going to, I just brief information, see what is the main of an FDM 3D printer. What happens, you can see a filament spool up there. So that green filament spool, it goes inside a extruder. Extruder is basically if you remember the sugarcane juice, ganne ka juice we have, you can imagine when ganna goes in and the juices come out. So it's very similar to that, and there is a heating chamber here through which there is a small hole where your filament comes out, melted filament comes out. This is another technology where liquid is used. You can see in this photograph there is a projector from the bottom. So here the layers are made using liquid. So this is right now out of scope thoda. So let me explain it in a very simple manner. The fuse deposition modeling, the method we are using. So we are using a robot, okay, to move a object, okay. And for extruder, you can imagine it as a glue gun, okay. So this is the glue gun. So what we are doing basically, we are squirting plastic on a surface, and when the where the plastic is squirted is decided by our 3D printer. And as one layer is solidified, we build another layer on it. Does everybody have problem with sound? Okay. So this is the other. This is what happens. So 3D printer is basically multiple of 2D printers. Basically, we are making multiples of 2D layers. Imagine we are making something out of cardboard pieces. When we see it in person, we will understand. So in this photograph, you can see these lines. These lines are made out of plastic. Okay, this is the hardware. As I mentioned, X, Y, and Z axis. X is left and right, Y is back and forth, and Z is up and down. This is again another example of the hardware used. This is the software which is used. So what happens? You require a 3D model to make this. So 3D model is not a photograph, you have to understand. So 3D model is made by, you can either 3D scan it, that's the one technology which is not common. Then another way is you just use your AutoCAD like software, and we are going to use another software called Tinkercad today to showcase it. These systems, you can make whatever you want in 3D modeling. It requires a little bit of skill to make that, but whenever you have done with that 3D model, the software which is developed for this 3D printer, it can just take that model and just recreate it as, like I would say, 0.2 mm accuracy on the 3D printer. Okay, So this is what you saw on the left is the 3D model. Then the right is what software came out with. Software decided where I want to put the plastic, how I want to put the plastic, and after you have this 3D print, which is the object that was designed before. So this is my early journey. So what happened, I was in a robotics competition, and when we won some state level stuff, and what happened is we won a sort of a voucher for a course, and that course basically got us into a 3D robotic arm. We made this robotic arm. This was a newspaper article. Then we had trouble making this 3D robotic arm, so I made this machine, CNC cutting machine. The machine that I mentioned earlier, which was subtractive technology, where we just take a wooden material and just cut it out. Here we are just making a drawing, and you can see here a small dinosaur's photograph. Okay, so this dinosaur was made on this machine. So this machine cut out the wooden parts and made the dinosaur out of it. This is 3D printer. This is article came in Times of India. So these are some of my 3D models. So when I started making this, I started selling these also as kits. So whoever was enthusiast can buy them. So this is the one. This one I was showing in IIT, if I'm correct. This is another 3D printer. If you can see on the right, it actually can fold itself. So you can fold it and carry, and it's a sort of a clone of another popular model. So you can fold this. This is another model that I was working on. We call it Machine X. The left one, so this is another popular model. So it is named Prusa i3 or Prusa, and the Prusa is the name of the man. On the right you can see he is very influential in 3D printing. He lives in Czech Republic in Prague, and right now, his 3D printer line is, I think, the most popular in the world, I would say, and they are all open source, so they are not keeping any patents, and they are still making business out of it. This is my mentor, Mishkin Ingaule. He has found many companies. Right now he's working in Spain, but he helped me make my career in 3D printing and the business side of it, so I'm thankful for him. This is another machine I built, which is like my last version. I want to show you some applications of 3D. So I'm a fan of movies. So this is a movie called Hellboy, and you can see this gun in this Hellboy. So what I did, I downloaded the 3D models and made this gun in 3D printer. So of course this is not a real gun, it's a toy, and I just painted it. Very similar to if somebody is playing Counter-Strike. This weapon might be known. It's a very coveted weapon called Karambit. So I also 3D print it if I want to. So that's the beauty of it. You can change colors in between of 3D printers. Different colors you can make. This is my college project for third year. It was basically a CCTV camera model. This is my BE project. I don't know this file will work. No. So this was just Rubik's Cube solving robot, and this is the part I made for that project. Very simple. This is the Iron Man helmet, also 3D printed. I have made one, but it's in the office. I don't have it right now. One more advantage of 3D printing is you have to carry only the raw material if you are so you don't want to carry, like imagine if you want to make a spanner for a specific specification. So you have to carry every spanner because you don't know what you will need. But with 3D printer, I can just take a piece of plastic and just print it wherever I want. So this is actually a wrench made in International Space Station with the 3D printer. So the technology is very versatile. This is another use. We all know Jaipur foot is a very popular prosthetics in India. So using 3D printers, we can make prosthetics for children. And the advantage of 3D printing is the material cost of this whole thing will be about 500 rupees instead of in lakhs sometimes. And as children grow up, you need to upgrade these very fast. So making them out of 3D printer makes a lot of sense. So this is another company is making. So this is a Wolverine themed. So they are collaborating with Star Wars and Marvel to make. So there are a lot of use of 3D printing. So now with 3D printing we can extrude a plastic, but we can extrude other materials also. So this is an example where basically chocolate is inside the syringe, and it is used to make a chocolate food, chocolate 3D print. So you can make a small toffee or chocolate, which whatever shape you want, completely customizable. So you can imagine these things in 5-star restaurants where you want very customized, or high-end cafes. This is another thing. You can the 3D printing houses also in China. So this is 3D printer which is depositing concrete layer by layer and making these houses in 24 hours. So you can imagine how fast you can do 3D printing when it comes to even large scales. This is another view. So this was not in China, it was, if I'm correct, in America, and it was made by basically a father for his daughter, that she wanted basically a princess castle. So he made a 3D printer which can work on concrete, and he made this castle out of it. So it's very wonderful thing. This is a very nice moment where I got to meet Abdul Kalam sir, and it was very momentous occasion where I got to show my work to him, and he was very encouraging. So this was the presentation, and then now we will move to the 3D printing part of it. So if I'm correct, yeah. So what we are going to do today for demonstration, we are going to go through basically whole cycle of 3D printing, which is starts with designing. Okay, so we are going to design it. So what we are going to use, we are going to use a website called Tinkercad. Okay, you can go and register yourself whenever you want, when you have free time. So in this website, this website is basically a 3D modeling software, but you don't have to download it. It's online. So what you can do is on the right side you can see there are various shapes here. Okay, and you drag and drop these shapes here on this main page. You can zoom in, zoom out. Okay, you can change the size of this. You can put exactly how many millimeters you want, and you can make your objects out of this, and you can combine and subtract. So for example, let's see, I have this block. Okay, I can name it green, I can color it green. Okay, the color here doesn't matter, okay, because color is only for representation here. Color is only for representation here. Then what happens is, imagine I take another, let's take, I want to make a small house. So this is a roof. So I can keep this roof on top, okay, and what I can do, I select both of them, okay, and click merge. So what happens when they are merged, they are now one piece. They are no longer a separate piece, they are one piece. Now on the other hand, what we can do is take any other object, and we can, as I said, I can change the color. So I can set the color as whole. Okay, so whole is, you can say, as negative. Okay, so I define it as whole, and when I group this together, okay, it carves the piece out from my main model. You can see the spherical part is carved out. Okay, so using this method we are going to make a simple keychain. Okay, so what we are going to do today, we are going to take this text format. Okay, so we have this text, so we are going to type something here. So we'll write MSS. Okay, and this text got its dimension, so it got a height of say 10 millimeters here, but because we are doing it, you want to print this model also, so I'm going to decrease it to just 5 millimeters. Okay, so you can see we have made this text. Now if I go and 3D print it right away, what will happen, it will create 3 letters MSS, but they are all separated. So there will be like letters we are used in number plates or something. So what we are going to do, we are going to take a box.
Hello, Karan?
Yes? Yes?
Sorry to interrupt. Actually, I think there is some lag between the presentation, the screen that you are presenting and the voice. So
okay.
I would just request you to hold on, because I think right now the part where you were speaking of MSS to be printed is actually getting showed right now.
Okay, got it. So I will go slow thoda. Okay, thank you for feedback. So
and do keep checking the view
chat. Oh, view, yeah, I'm checking it actually on my phone. Okay, so these alphabets, if I print them as it is, they will come as separately. So what we are going to do, we are going to take a box. Okay, I have taken this box here, and I'm going to put the height as 2 millimeters right now. Okay, I will slow down a bit. Then let's color it differently. Now what we are going to do, we are going to increase the size of this box. We'll make sure that it fits this size. So if you can see it here, MSS is on this plate. Now when I print this, what will happen, because of this plate, this will be more of like erased lettering, or whatever is opposite to embossing. So what we are going to do, as we are making this as a keychain, so we require a keychain hole. So what we are going to do, we are going to take one cylinder, okay, and as I showed you before, what we can do, as we can combine objects, we can remove them also. So I will define this cylinder as hole or negative cavity. I'm going to make it smaller, okay. Let's say 10 millimeters by 10 millimeters square. So I can type 10. I will zoom in so you can see it clearly. Now we are going to take this sphere I made and put it where I want my hole. Okay. So what will happen when I combine all of these three parts, which is our MSS lettering, the base plate, and this hole, it's going to make this into a one object. But as you remember, we kept the cylinder as a whole. So what will happen? It will just remove that part from my main model. Okay. So what we are going to do, this keychain is ready. It's just very simple design, and we are going to export it into an format called STL. Okay. So if you know Photoshop or CorelDRAW, you know you can export file in a format called JPG. We are all familiar with JPG format. It is a very common format for our photographs. But when you have exported it once, say from CorelDRAW, it's hard to edit it. So similar thing with this, the STL format, when you export it, you can't edit it easily. So I'm going to save this. And now I'm going to introduce to another software which we are going to use very briefly to basically convert this model so my 3D printer can understand it. Okay. So these softwares are called slicers. Okay. These are specifically made for 3D printers only. Okay. So what they do, they take a 3D model and then convert into a language that my machine can understand. Yeah, we can use Blender also. We can use any 3D. I got a question. Yeah, you can use Blender also. So what will happen? We are going to import our file we just downloaded. You can see it here. So this square piece is my build plate of my 3D printer. So this is as big I can make an object. Also there is a height limit also, but it is not shown here. So I'm going to just place this MSS in front, and there are a lot of settings involved in this. I'm not going to in depth in the settings, but basically I select the settings. Yeah, I will answer the questions afterwards. Okay, when we are 3D printing, I will go through the chat and maybe answer them. So what we are going to do is when this model is done, so software automatically slices it. The process is called slicing, and we can see the slicing view. So you can see here, if I go in zoom in detail, these orange lines are basically outlines of my object. Okay, so 3D printer is going to draw those with molten plastic first, and then he is going to fill the red part. And if I go down, I can see how it's going to get printed. Okay. So this is my bottom layer. So this bottom layer is what attaches to my build plate. Okay. Then it goes up. So now the two layers are done. It's going to do, you can see this triangular pattern here. So when we are 3D printing, we don't actually print complete solid objects because it's going to be waste of time and materials. So what we tell the software that, hey, we want this percentage of fillness, or it's called infill in 3D printing terms. So we have set it to 15%. So right now the object is filled by plastic 15% by volume. So as we go further and further, so it closes our top plate and then goes for the lettering. Okay, you can see. So this whole print will be of 21 layers and it is going to take 20 minutes. Okay, so what we are going to do now is I'm going to send this file to 3D printer. Now my 3D printer is attached to my Wi-Fi, so I don't have to connect it to my PC, or in other 3D printers the method is that you require an SD card to do that, but we are just going to send it to our 3D printer. Yep, and it just sends wirelessly and it starts 3D printing. Okay, so right now I will show you another view where you can see my 3D printer's basically interface. Okay, so this is something called Octoprint. It's working on a Raspberry Pi if anybody is interested. So it's basically a small computer on my 3D printer which makes its own server page, and I connect it through that. So you can see here these graphs. Let's see if I can increase the size. You can see, yeah, you can see that our temperature is increasing. Okay, so I told them to increase the temperature, and you can see, so this is random file, this is when it was uploaded, and this is what was the size. It's a half MB of a file. If I show you the same view, I can see it here, the G-code view. Let me explain. So this is basically a live view that it will show us what is getting printed right now on the machine. And after this, when the 3D printer has started, I will move to my phone camera and I will show you the 3D print. Plus one more thing, actually I can show you right away. So this is actually, I attached a camera also, so I can monitor it from anywhere. So it actually connected to internet also. So if I'm somewhere else, I can connect to my 3D printer and see what is the progress. So what you are looking at right now is the head of the 3D printer. Okay. Now I will. I'm closing the presenter access.
Okay. Karan, sorry to interrupt.
Yes,
Just one announcement that for those of you who are not able to see the details in the screen clearly, you can zoom into that part of the screen and you can again zoom out. So you will be able to see those specific details clearly on your screen. Sorry to interrupt.
And I will also try to zoom in and try to hold your phone horizontal. Yeah.
Yeah, I think from your end, if you try, there might be some lag and we don't want any issues there.
Sure.
So for those people who want to actually view it in detail, they can zoom in and zoom out.
Okay. So so I will show you my my phone view. You might have to click on the camera view that I have, and I will show you the 3D printer. Just
so on top right corner, if you can see, there is Karan's camera view that is already on. Or Karan, if you turn off the presenter screen, you can actually put it on main view. Or you want to show something on the screen? Hello, Karan.
Oh, sorry, I was on mute. I was saying, can I just stop the screen sharing right now, or should I?
Yeah, that's what I'm asking you. That's what I'm asking you. Do you want to share anything on the screen while the demo
I don't
is going
want to. I don't want to anymore. Yeah, I will just stop it.
Yeah, yeah.
If I require, just I will ask you. Okay.
Okay. Okay. No problem.
Okay, I will stopping it so they can access it properly. So this is the 3D printer. Okay, so what is happening, let me try to explain. So on the back, this and this, these are two motors here which are controlling this center section. Okay, so two motors in the background. So what is happening actually right now, this bed is getting up. So now if you see, there is this filament going in. Okay, this is the plastic, so our object will be of blue color. Okay, so what is going to happen, this plastic is getting pulled here in this unit. This unit then pushing it and is out of, right now you can see the plastic is coming out of blue color. I can show you from this angle. Wait. So you can see it's actually putting the plastic. I will keep in the horizontal only, so it's consistent. I will keep it steady. So there are few fans also, because to help the cooling of plastic. So the bottom layer is generally printed really slowly, because we need to make sure that it is getting stuck the bed properly. So let me give you another overview when it's printing. So as I told you, there are two motors in the back which will help in the motion, X and Y motion. Okay, two motors in the back. Then there is another motor which is actually inside this body, but is attached to this middle rod. You can see this middle rod. So this middle rod, when it rotates, it's like a screw. When it rotates, the bed goes up and down. Okay, so whenever one layer is drawn properly, the bed will go down thoda sa, about, say in this case 0.24 millimeters, 240 microns. It will go down, and the 3D printer will start printing on top of it. Now there is another motor hidden inside this unit. This motor is actually doing the job of pulling our plastic. Okay, and it's hard to see. So inside here there is a nozzle. This nozzle is right now heated at 200 degrees Celsius. So what is happening, due to this 200 degrees Celsius, the plastic is getting melted and the plastic is coming out of a nozzle. The nozzle's diameter is around 0.4 millimeters. It's exactly 0.4 millimeters. Then by this information our machine will know how much of plastic to extrude. There is another fan which will turn on afterwards, like right now. So now first layer is done. Now machine is also sped up. So see, it's doing outlines first. Then it's going to start filling the inside part. And what we are going to do here is, when our base plate is done and it's time for lettering, I'm going to stop the 3D printer in middle and change the filament to another color. So you can see the difference and how you can do say multicolor printing here. So it's a typical for keychain. If you change it middle, you can see a nice contrast of the 3D print. So you can see. So meanwhile, I would like to show some other 3D prints that I have. Okay. So So this is a model of Ganpati. So this was again downloaded, and I think so this was made by a method called photogrammetry. What happens with this method is, you take multiple photographs of an object, in this case a Ganpati Murti, and you put it in a software. What software will do is basically try to understand how the model actually looks like and try to convert into a 3D model. The quality is not always good, but you can get a generalized idea. Now another thing I was actually printing for preparation of this is, actually this is basically a mobile stand I was trying to make for tripod. I was just printing one more part, so I could have done basically a phone stand instead of me holding it in the hand. So if you can see, there are these screws here. So this is a nut and screw. So this is nut, screw and bolt system here, and you can just, so you can see how tight tolerances you can get. or how tight accuracy you can get. This is another fun print. This is basically my glasses holder. Very simple 3D print, little fun. So right now, the corona pandemic is going on, and right now we try to make these masks, so you can add filters in them, and filter can be replaceable, and this is actually an FDA approved design. So the advantage of 3D printing is I don't have to wait for a manufacturer to manufacture it. I can just make it my own on 3D printer. And another thing we are actually making with a group of people called We the People. It's like We the and double P people, PPE. So these are face shields basically. So face shield, yeah, I will show you. So this part 3D printed again in 20 minutes, and this is a sheet. So this is used by, so this is used by medical and police professionals. So they can use them for, it's like an addition to mask, so nothing gets on your eyes and skin. Another thing, another simple object, this is a phone stand. Okay. Phone stand is broken, it's fine. This is, I like to make these kind of things. This is basically a hunting knife from a video game called Destiny. I like to make stuff from video games and movies. So this is again a 3-part print. So my machine cannot print this big. So I have taken the model was made in such a way that there were 3 parts, and then you combine them with it. So it's pretty big print, you can see. Another thing I would like to show is, so including this 3D printer, I was just talking about another 3D printer, which is a liquid 3D printer, which can do, you can see, this is very highly detailed. This is a denture. It's basically when you are doing root canals or adding new implants, this is basically a custom made. So the doctors send me this file. So they have taken the scan of the tooth structure and gums, and then decided where they want holes and send this model to me. Now they are going to use it, so they are going to add it on patient, and using these holes as guide for drilling.
Karan, there is a lag on the video from your side, and also you are not audible. Please ensure there's connectivity on your end, Karan.
Hello.
Yes, Karan,
Yes, you are audible, Karan.
Yeah, okay, great. So yeah, so this is, I was telling you, yeah, this is used for drilling the holes in your gums, so they can add implant. So this is liquid 3D printer, so you can see it can do very minute details. So this is a small ring. Again, these 3D printers are used a lot in jewelry industry, okay, and now they are getting quite affordable. Because again, just like our normal 3D printers, they have lost their patents, so now they can be used. Another things I would like to show.
Hey Karan, wait, wait for a minute. Many people are not able to see the video.
Yeah. Okay. I will wait.
So can we take some questions?
Yeah, I can. No problem. Yeah.
So yeah, so
And
I have noted all the questions, so you can answer them directly.
Yeah, please.
Instead of going through.
Please.
Okay.
Yeah, please, sure.
So,
Which part did you miss?
just wait. Okay. The Karan asked, which is better to use Blender or Tinkercad?
Okay. So Blender is, if you don't know, Blender is an open source, again, a 3D modeling software which is used by a lot of animation studios, animation people. The thing is, Tinkercad is only good for, let's say, mechanical objects. Okay. So if you are making some like part or robotics project or anything like that, that is perfect Tinkercad. But Blender is good for like overall. You can do like character modeling and everything like that. So, but Blender is very difficult to learn, honestly. So Tinkercad, like I have taught children of like 5th to 6th standard using Tinkercad to make their own keychain and different objects. So I would suggest, if you're starting new, Tinkercad is better. If you're already good with Blender, go for it.
Okay.
Just before one question, what I'm going to do, I'm going to pause this print and going to change the color. Okay.
Karan, there is no video link from your side for some reason.
There is no video.
Yeah.
Yes, Karan, there is no video.
Yeah. Let me check.
You may have to rejoin. Yeah, or just check your controls once.
Yeah. I will rejoin. Okay.
Okay, and then let me know which one are you using. MSS volunteers who are right now not speaking can put themselves on mute, so there is no ambient noise. We're sorry for the pause in the session, but I think the speaker has some technical issues in connecting, so he'll be back soon. I think he has already joined.
Hello, can you hear me? Yeah.
Yes, Karan, we can hear you. Yeah, and we can see the printer also.
So in meanwhile, I changed the filament from blue to black, and you can see right now. It is making the object now in black color.
Yeah, just two quick points for those who can't see the video. On your top right, if you can see that Karan's video is playing, you can just click on it and it will appear as the main view, or you can just click and hold and you can lock the view on that video. And the second thing, it is best viewed as horizontal view, because currently I think Karan, you are showing it horizontally. So all of you can just rotate your screen to horizontal view so that you can see the entire screen, entire video.
Yeah, can I get more questions?
Yeah, so Dhwani is asking, is it possible to develop human body organs and also other eatables using 3D printing?
Okay, so yeah, there is a lot of work going on to make human organs out of 3D printers. The idea there is to make, like what I have read so far, is making a structure out of sugar or some kind of material that our stem cells will require, and then stem cells will build around that object. Like imagine a small sugar tube, and the cells will develop on them. They will eat the sugar, but then they will create a coating of cells. So yeah, there is some happening in biology. In terms of edible, yes, you can, there are chocolate 3D printers, there are sugar 3D printers. So in the sugar 3D printer you can have colors also, because there is a small inkjet model on that, inkjet module, so it can have edible colors. So there are 3D printers like that. If you want to search, there is a 3D printer called Houdini, like Houdini with a food. So Houdini is a 3D printer which is specialized in food 3D printing. But you can modify this 3D printer for simple chocolate 3D printing or cake decoration without any issue.
Okay, thank you, Karan. Vikrant Mahulkar asks, are all 3D printers able to read only G code and STL file?
Yeah, so not all 3D printers. So let's see. When it comes to open source 3D printers, all of them read G code. Okay, that is the standard. But there are, like, some companies try to, you know, to avoid other people's hacking their machines. So they have their custom format. But yes, but none of the machines can read directly STL unless you do a lot of jugaad there. Like, I can make it like that where, okay, I fit an STL file, then my Raspberry Pi will convert into G code. But end of the day, the G code is what requires for 3D printer. But doing from STL to G code is the process of 2 clicks, honestly. So it's not a big deal. But you cannot just take any random G code you got from other 3D printer and use it for this. Okay, because each printer is different. So there are customization involved with the printer, what material you are using. Like, for example, the material that we are using is called PLA, polylactic acid. So it's a very low melting plastic and it doesn't require, it's not fuss anymore. But there are other materials like PETG, which is similar material as our water bottles. That will require different temperatures, and in this 3D printer, this bed is also heated. There is a heater which is heating this bed. Right now it's at 60 degrees Celsius. So yeah, G code and STL, you can use all the STL files for 3D printing, unless there will be some limitations. You cannot print too small, you cannot print too much of a detail beyond a certain limit.
Okay.
I'm sorry to interrupt, Karan. Everybody, are you okay if this session is extended a little bit? Because looking at
no
detailing
problem.
of the session, I think it is going to take more time.
Yeah, no issue. I'm happy.
Okay, thank you.
Okay, another question from Satish Patankar. How does the material with different colors is monitored from the extruder?
Okay, so there is no control of the color. Okay, so machine doesn't know what color is going in and etc. So whatever the material of this color is, it's going to get printed. You have to change it manually in the middle. Now this is, I'm talking about this normal 3D printer. There are 3D printers which can print in color. Okay, so how that happens is a little complicated to explain, but basically they use powder and an inkjet cartridge, where they have, instead of normal ink, there is some glue kind of a ink there, and with that it can generate colors in 3D print. There is another way of doing multicolor printing, where there's this company called Mosaic. They have built a machine called palette. What happens is you feed all your materials, like maximum 4 materials or 4 colors. It can be different materials also, mind. So then there is some magic happening on the software side, that you can decide what color you want of which part. I am talking about 4 distinct colors here, not a mixture of colors. So I cannot make RGB here. So in that system, it actually, the machine, the palette machine, sends different filaments. It basically like if it's want to print this, so for if I want S in different color, there's M in different color, it can do that, because it calculates accurately where my filament will end, and then changes the color of the filament in middle. So color changing is not a big deal, in a sense that it's not important, but more important is, can you do different materials? Can you do one 3D print with different like I can have flexible materials also available. Okay, flexible filament. So I can use that, and rigid filament. I can make a spring type structure. So yeah, right now it doesn't monitor color, what is going in. It doesn't know color at all.
Question from Karthik Pankaj Pathak. can we code our 3D printer using Python?
Okay, so no. What is happening in on the 3D printer side here? The code, the board right now here is an Arduino or Atmega based board, which is the whole software is written in C or a version of C, and it is taking everything. So from Python, if you make a Python script for make a 3D model, yeah, you can use that. But end of the day, 3D printer will require an STL file, not another kind of code. So I don't understand completely what, because Python is such a huge language. So actually this softwares with the slicer software you saw were actually very old versions were Python based only. So right now our 3D print is done, the machine has parked and the bed is coming down. I will let it cool down and I will remove the print to show you. Yeah, next question.
Okay. For a moment. Okay. Pranav Oak is asking, can Blender be used for both modeling as well as slicing purposes?
No, Blender is only modeling. For slicer you have to use some other slicers. There are various slicers in market. I would say 90% of them are free. There is only one slicer which is paid. And generally when you buy a 3D printer, because this printer is made by me, so it's not available in market. But nowadays you can get 3D printers on Amazon for 15,000 rupees, and it's pretty good honestly. It's not a bad 3D printer at all. So with that 3D printer, the software comes by default, and when you go on internet, you will find various different software options.
Mr. Sadekar is asking whether 3D printer can be done with only plastic material only.
Yes, right now the printer that you are right now looking at is only for plastics. But yeah, only for plastic. But this plastic is actually not even oil based. This is a corn based plastic. It is biodegradable, but not at a like biodegradable as a like a PETG is recyclable, but this is biodegradable at a like not the high grade but at a low grade. So it takes more time to disintegrate. But because we need certain properties in the material, so only the unfortunately plastics are the only thing that can provide this. But there are materials like, for example, I have actually, yes, I have a wax filament. So instead of plastic, it's wax. I got it from somewhere, I don't remember, from USA. But yeah, you can print with wax there, and there are some materials like that. It takes this PLA material and they add little powders of brass or stainless steel. I have actually made like a nylon plus carbon fiber, which is very strong. So there are this composite available, but base will be mostly a plastic.
Okay, Abhishek is asking how is does the finishing touch depend on the plastic material used?
Okay, so regarding finishing touch, I like to mention again, you can see these liquid 3D printer prints, they are very fine and very smooth. Okay, you can't see layers because each layer is about, say, I would say 0.02 millimeter each layer. So you can see the detail. You can see the detail in this snake ring. Okay, what I'm trying to say here, this is high detail stuff. Okay, here each layer is made out of about say 20 microns or 50 microns, which is 0.05 millimeters. So here you have amazing finish here, okay, because this is a liquid when it was made. Now this plastic, depending on what plastic you use, there will be a difference, okay. So the PLA and the ABS, the most popular materials where you 3D print, they give relatively good results. So if you want to see, for example, you can see the sides of this Ganpati statue, okay, it's pretty smooth. But if you want to paint it, then you need to add a little bit of primer, okay, a spray primer on this, and after that you can paint it. So, but there are some materials like nylon, okay. So nylon is used for 3D printing, but nylon doesn't print well. There will be always some problems with nylon. So yeah, but nylon prints generally are not for looking, they are for function. Because you have to understand 3D printer is not only about making these statues and all. you can make actual function parts. Like if I want to talk, this white part here, okay, this white part, and this part, like some parts here, these are 3D printed. So when at initial they mentioned, you can make a 3D printer out of a 3D printer.
Sorry, Karan, to interrupt. I would request all the MSS volunteers who are right now not speaking currently put themselves on mute, because what is happening is it is switching the main view of the person who is speaking. In that case, we are not able to see what you are actually showing. So obviously, and there is also ambient noise, which again the audience is referring to in the chat. So anyone from MSS who is not speaking, please put yourselves on mute.
Okay, I think it is because of me. Sorry. I will put on mute.
Okay, so to repeat myself, many of these parts, like this part, are actually 3D printed only. I can show you another parts here. This purple spacer is a 3D printed. So when I built my first 3D printer, the maximum parts were 3D printed. I won't do a presenter access, but I will quickly show you my first 3D printer's design. If you can see, all these orange and green parts are all 3D printed, and others are just rods taken from hardware store. Okay, so you can basically make a 3D printer out of 3D printer, and that is how the whole RipRap movement started. You can see the name RipRap. RipRap stands for Replicated Rapid Prototyping. The idea for making this 3D printer was it should be able to replicate itself. So when you have one 3D printer, you can make many 3D printers. Yeah, next question.
Okay, two more questions from Satish Patankar. Do we have different printers for different final products? Are they convertible, and what is the cost of the printer that you are showing right now? It's a big question.
Okay, so let's go step by step. First of all, let's go for the price. So this printer I built generally for like 40,000, but it's got a lot of R&D gone into it, and generally I don't sell them anymore. We sell a different version of this to schools, but it comes with a warranty and everything. Right now I'm not in the manufacturing business, but soon after this, actually before lockdown, we were planning to make a very cheap 3D printer that is like good also and made in India. So yeah, we are working on it. So right now this is 40,000. If I'm getting the other question, it was the different types of printer for different kind of finishes, right? Am I correct?
Yeah. For different final products, are there different printers?
Yes. Okay. Yes. Depend on what the final product is. So if it's jewelry, you will go for resin printer. If you need hardware pieces fast, you go for FDM printers. Okay. If you want them strong, then you use materials like ABS or PETG. If you want them flexible, use flexible printer. So it's a combination of materials and printers. But generally, a printer decides sort of what its capability is. Okay. Capability I mean by how detailed it can go. What kind of materials, what kind of material inputs you require. Like this require a plastic filament like this. This rod of plastic is required. Okay, but here we require a liquid resin. So different printers are there. Okay, for different, but it depends on the use again. And one more important thing, we should not look 3D printers as mass manufacturing at all. So this is the mindset we need to move out of. Okay, so let me explain. So I have this camera. Okay, this is a Sony PlayStation whatever camera. So the shell of this part, if I go for 3D printing, it will take me 3 hours. But in their factories, this is made in like 5 seconds. Okay, so you should not look 3D printers as manufacturing. What you can do is, if I want to make this, and if I want a custom name on the back, or I want everything in a different color, then you think about 3D printing, where customization is key. Okay, for example, I cannot make this in normal manufacturing because each person's teeth structure will be different, every requirement will be different. So you generally need only 1 or 2 of these pieces. Or talk about custom jewelry. So in that case, you should look at 3D printer as a prototyping and a customizable tool. So like if I want to make this keychain in conventional method, I have to take at least like 10,000 or 5,000 minimum orders to make this in a mold, and mold will take another say 25,000 rupees to 30,000 rupees. But here I can make one of these for, like, if I go for the cost of this material cost, I took 4 grams of plastic, which is 3 rupees is the cost of this basically keychain right now. But I don't have to put that much investment, and the turnaround time was much faster. So when you're doing prototyping, for that 3D printing is perfect.
Okay, one more question. In case of architectural models, does it require 3D model of it from architectural software, or detailed AutoCAD 2D plans with all dimensions, height mentions are enough as an input?
No. So if you have a 2D model, it won't be enough. You want a proper 3D model, so you have to use it your AutoCAD, or you have to use let's say SketchUp. SketchUp is another old software which was owned by Google once. These softwares you can use. You need a 3D model. You need a 3D model to do that.
Okay, we are
Okay,
on to last two questions. Okay. Can we take 2 more?
Yeah, sure.
Yeah.
Yes, Aditya, so just end in these last 2 questions, and then the conclusion, or the what thank you note can be given by Sachin. I hope he is there. And yeah, so we'll finish with these last 2 questions now.
Okay, so Karan, one viewer has asked, can we use cartridge like thing to, like we use in flex printing? Can we do it here?
No, instead of cartridge we have filament plastic here. Okay, so the material is different. You should not look it as a normal 3D print, normal printing where you have a normal liquid ink cartridge. So so you should not look. So 3D printing is a term which is very how can I say, it's very fancy, but the proper name for the machine will be a rapid prototyping machine. Okay, so you should not equate it to normal 2D printing or flex printing or your paper printing. So no, that is, you can't use your flex inks for this.
So one more question regarding the colors. Can we add different extractors? So can we use different colors, and can we program them to make different?
So that's so that is something called multiple extruders. So what happens, there are many companies have tried this to master this technique, where you have 2 extruders or more extruders. There are a lot of challenges into it, like aligning and calibrating both extruders, but you can do that. So I would say the most current best method is something called tool changer. So what happens, I will just show you. So you can see there is one extruder here. So in that system there are like 4 extruders kept here. Okay, 4 extruders kept. Our machine goes and picks one of them. Each one of them have already put filament or the whatever color filament or different material already put there. So machine goes there, picks that up, prints with it. When that is done, it parks it and then picks up the new cartridge. Okay, it's called a tool changer 3D printer. You can Google it. It is developed by E3D. It is in Europe. So it's not like a final product right now. It's in very much prototyping stage because people are doing a beta testing for it. But I think that is the best method to do multiple. So yeah, you can have multiple of these units. But imagine if I add 4 of these units, I can't move much here. So something like a tool changer method. There is another method where you have a Y strip here, a Y splitter. So there is a filament going here from there, and instead of motor being here, it's at the back. So it can actually pull one filament and push another filament. I have tried that myself. It's not easy to calibrate at all. It's not reliable. But this is called multiple extruder or multiple material 3D printing. And yeah, it is very sort of common, getting common. But people are still thinking that FDM is a technology where you should not do this. It is not made for it. Yeah.
So I think I've covered all the questions almost.
Yeah.
That's it for the questions.
Okay.
Thank you.
Okay, so I see that Karan, you have done a really great job in terms of explaining the entire process of 3D printing, the different techniques involved in it. Also, the live prototype that you made, that one keychain that you made was really great to see the demo of it.
Thank you.
And a working model, and we understand how it was important because actually you did it in a very short span of time. You agreed to have this session and also get along the live demo of it and set up your printer and everything. So it's really great to see this enthusiasm, and thanks a lot for we are grateful to have you here today. Thanks a lot for this session. Closing remarks by Sachin, and then we would end the session for today. Thanks
just
to
one
all the
thing,
participants as well.
Just one thing, if somebody have any questions, you can contact me on my Facebook, maybe Karan Satish Chaphekar. You can contact me through there. I have Instagram, I don't know what is the ID, but yeah, you can contact me there if you have any questions regarding 3D printing. I would love to help you out.
Yeah. In fact, in the feedback form also, we will have one section of questions for those who attended to actually put them down, and we'll forward them to you, so you can actually respond to them as well over email. And today's session, thanks a lot again. It was really great, and thanks to all the participants also. I think we had good attendance today. So over to you, Sachin, now.
Yes, really great session, Karan. Thanks a lot. And yes, moving forward, I would like to announce our next session that will take place on next Sunday. That will be given by Dr. Shrikant Karlekar. He is a geologist, and our topic of the session will be climate change and its effects on mankind. So stay tuned with us, and make sure you fill out the feedback form. And we can see that there was a lot of questions. I mean, since this topic is very detailed topic, and Karan went out in explaining very deeply, but since we are running out of time, we have to stop here. And thank you very much for joining this session, and hope to see you next week as well. Thank you. Thank
you all. Thank you all.
Thanks a lot. Yeah. Bye.